Hello there, children. Today, we're going to work with piecewise functions. This educational experience is brought to you by your paladin of piecewise, Sir Faust indeed. So, let us begin. Now, what is a piecewise function? Well, it looks like the following. It looks like our regular f of x, our function notation, and an equal sign, so that's not a big deal. But then it has these two particular pieces. Now, what this means is the following. These are what we call our little constraints, so to speak. They are telling us what we can do where. Now, you see this 2x plus 1. That is an equation. We can use that equation 2x plus 1 only where the x values in my function are less than 1. If the x's are greater than negative 1, we will use this function over here. So it is really telling us where I can use each one of these functions. So let's take a look at what that will look like. Now, let us say that I graph the following function here. Now you're wondering, how do I graph these things? Well, what I am going to do is I am going to put x being negative 1 into that function because I want to find out where exactly I'm going to start here, because x's must be less than negative 1. So I put negative 1 into that top function. I'll do this function in orange. So I put negative 1 in here. 2 times negative 1 plus 1. Negative 2 plus 1, that's negative 1. So at negative 1, negative 1. Now, I'm going to start this with a dot. What type of dot am I going to use? Open dot, if you remember from earlier when we graphed linear inequalities, that's not less than or equal to, so I use an open dot. At x being negative 1, the y being negative 1. An open dot there. Now, I need to figure out where the rest of this graph is going. Now, my constraint told me that I am only allowed to use this 2x plus 1 for x's less than negative 1. So where x is less than negative 1? To the right or to the left? To the left! Thank you, imaginary voice in my head. If you think about it logically when we graph linear inequalities, remember the arrow points to the left, my graph will be going to the left. So now I need to figure out where to go. I have this line right here. I'm going to use that slope of 2 to get to my next point. Now if I were here, usually I would go up 2 to the right 1 because I have a slope of positive 2. But I'm not allowed to do that because I have to go to the left because that arrow points to the left. So how do I, instead of going up and to the right, I'm going to go down and to the left. And I'm going to end up graphing a ray, which if you think about it makes sense because I'm only allowed to do 2x plus 1 for part of this graph. Now, I'm going to graph the other graph in purple. Now, I'm going to put negative 1 into that function. It means negative 1 plus 4. I get 1 plus 4, which is 5. What type of dot am I going to use? It is going to be closed because that is greater than or equal to. So x being negative 1, my y is 5. 1, 2, 3, 4, 5. Closed dot. Now, which way do I have to graph? To the left or to the right? To the right. Thank you, imaginary voice, because my arrow points to the right. That's where I have to graph. How am I going to use my slope here, which is negative 1, to go to the right? Well, I go down, which is negative, and right, which is positive, which that's how I get that negative slope. Now, the question I have for you is this. What was this section called? It was piecewise what? Piecewise functions. If it's a piecewise function, it has to be a what? Function. Thank you. It has to be a function, which means it needs to pass the vertical line test, which this graph clearly does. Because if I draw a vertical line right here, I hit it once. That point, remember, is an open dot. It's not really there. So if you're ever wondering if you graph these things properly, remember, this is a piecewise function. It has to be a function. if you ordered a bacon cheeseburger and it came with no cheeseburger or no bacon, you, like myself, would be super annoyed at that fact. Piecewise functions must be functions, which means they must pass the vertical line test. Moving on. All right, so now I graph this particular function. Now, the first thing I have to realize is where is my quote-unquote split happening, which means what values am I going to be putting into this function? And the answer is found right over here at 1. So what I'm going to do is I'm going to graph this first function in green. I'm going to put -1 into that function here. Excuse me, put 1 into that function because that's the value I want right there. 2 times 1, that's 2 plus 2, which is 4. So at 1, I get 4. What type of dot am I going to have? Open, because that's in greater than and not greater than or equal to. So at 1, 4, I have an open dot. Now, which way am I going to shade? To the right, or to the left? Well, my arrow points to the right here. That's how I shall be shading. So I use this graph and its slope of 2 to get to my next point, which means go up and to the right. And I graph. Arrow at one end because it's a ray. It's not a line. Now this other graph, I am going to put in what? Oh, let's graph it in red. I'm going to put in 1 into that graph. That was pretty boring. It's 1. So what do? Well, at x being 1, my y is 1. That's swell. Closed dot, however, because it is less than or equal to. Now, I use this line as a slope of 1. Usually I would go up and to the right. Not allowed to do that because of 2 reasons. 1, it told me I need the x's less than that, which are to the left, because my arrow points to the left. And secondly, if I went up and to the right and graphed it like that, it would fail the vertical line test, which would be very bad. And it wouldn't be a function. And it was guaranteed to be a function because these are piecewise functions. So instead of going up and to the right, I am going to go down and to the left and graph my ray. Passes the vertical line test, so we are all good, as they say. Moving on. Okay, so now, as I look at this function here, f of x plus 2 is x greater than or equal to 2, and negative x minus 3 as x is less than 2. So what do here? I'm going to graph this first one in blue. Now, what point do I put in? Remember, this is where my break could be happening, or my jump could be happening at x equals 2. So what I'm going to do is put 2 into that function. So I get 2 plus 2. That's 4. So when x is 2, y is 4. It has a closed dot there because this was greater than or equal to. And because it's greater than or equal to, and my arrow points to the right, I'm going to use that equation and go to the right. Which means I go up 1 over 1 because that's my slope. Now, the other equation, I'm going to graph in red. I'm going to also put 2 in there because that's the point that I may have a starting or ending point, so to speak, where they tell me I need x is less than 2. So I get negative 2 minus 3, that's negative 5. So at 2, I get negative 5. Open dot, because why? It is less than, not less than or equal to. Now, because my x is less than here, all x's less than go to the left because these are x's that are less than 2, like 1, 0, negative 1, so on and so forth. So, and my arrow points that way. So I need to use my slope of negative 1 and figure that out. Usually I would go down to the right for a negative slope. Not allowed to do that because if I did, it would violate the vertical line test, and plus my x's should be less than here. So instead of going down to the right, I'm going to go up and to the left. And there you go. This passes the vertical line test, which is what I was looking for. And it also, well, it also works for my function. I can go back and regraph this and check it, and this in fact works. Moving on. Now, it's all not just about graphing. We can also do some algebra manipulations. Say what? We can also find given values of these functions, but we must be careful. So tell me what the following are. So now, remember, if you recall our notation here for these functions, tell me what the following would be. They give you f of 2. What this means, remember, is simply saying that x equals 2 here. So now you must ask yourself, I have two possible functions. You are not to put them in both of them. That's not how this works. So what do I in fact do? Well, they told me x is 2. What these constraints tell me is, look, you are allowed to use certain functions given the x value is either greater than 0 or less than or equal to 0. So check your x value here. Check on the bottom. Is 2 less than or equal to 0? No, it's not. Is 2 greater than 0? Yes, it is. So because 2 is greater than 0 here, I am going to use the top function, meaning I am going to put 2 into that top function. There's my answer of 5. I will warn you, if this were multiple choice, I guarantee one of the answers is going to be 6, assuming you put it into the wrong problem, put it in the bottom here. If you think about this, this kind of makes sense. Think of driving. The speed limit on Cadmus is like 35 miles an hour. So if on Cadmus, right here, speed limit is 35. If on 422, the speed limit is 55. So given where you are, your x value, so to speak, will tell you what speed you are going to go. So I can't go 55 miles an hour on Cadmus. I will get arrested. Conversely, I can't go 35 miles an hour on 422. Someone is going to run me over. Many people. I will get crushed. Splat. Done. Not okay. So you must check yourself before you wreck yourself. Meaning, for this case, x is negative 2. Where is that function allowed to be used? Meaning, what function can I substitute this into? Look at the top here. Negative 2 greater than 0. No. So I can't put negative 2 into this function because that x value I gave me is not allowed. It's not something that this function was supposed to be used for. Can I go 35 on 422? No. You go down here. Is negative 2 less than or equal to 0? Yes, it is. So because negative 2 is less than or equal to 0, I put negative 2 into the bottom function. You don't need to put it into both of them because they both won't work. F of 0 means x is 0 here. Think of microwave directions for something. If you have an item that can be put in the microwave oven or the actual oven, they have different directions depending whether you're going to put it in the microwave or the oven. If you flip-flop them, it's not going to cook right. You put a pizza in the oven for 1.5 minutes, it's not going to cook. Conversely, if you microwave a pizza for 18 minutes, it will probably catch your house on fire. Not good. Not good. So x being 0 here, which function is this allowed to go in? 0 greater than 0? No, it is not. Is 0 less than or equal to 0? Yes, it is. So I substitute into the bottom function. Can't do it in the top function because that constraint will not allow me to do that. You are now ready to tackle the world and tackle these functions. Go henceforth and do.